Okay, so now we're going to work on doing some more interesting things in Python. First off, I'd like to point out that in the previous video I referred to this section of code here as a function. This is not. This is a for loop, and every time we start a code block we have the colon here, and so really this isn't a function, this is actually the code block that is executed as part of the for loop. So now what I'm going to do is I'm going to copy in some functions from a program I've written before. Okay, so let me go grab those. First thing we're going to do is we're going to copy in a function that's going to compute the slope. Okay, so we're going to compute the slope of that using that function, given a starting point, an x1, and an ending point, an x2. Okay, so we call the xfunc with x1, we get the y1 value. We call xfunc with y2, we get the y2 value. And as you remember from basic algebra, the slope is equal to the rise, or the difference from y2 minus y1, divided by the run, which is the difference between x2 minus x1. We do that computation, and then we return the slope. Okay, so that's going to give us the slope of the curve at any given pair of points, between any given pair of points. Now, if you've looked at the Khan Academy YouTube video on limits, what we're trying to do there when we're trying to compute the slope of a function such as x squared, y is equal to x squared, what we're trying to do is we want to make the difference, or the delta, the difference between x1 and x2, smaller and smaller and smaller. So what we're going to do here is I'm going to copy in another routine that's going to allow us to compute the limit at a particular value. So what I'm going to do here, let me grab that code, copy it over here. So now we have another function. So we have three functions. All right, my y is equal to x squared function, my slope function, and now a limit function. And what I'm going to do with the limit is I'm only going to pass in one x value, and I'm going to start with setting a delta value equal to 1. Okay, so the delta is going to be my difference between my x1 and my x2. And then what I'm going to do is I'm going to create another iterator. I'm going to have another for loop here, and in that for loop, so this is going to run from 1 to 32. Each time I execute, I'm going to divide the delta by 2. So the first time I run, my delta will be 1/2. The next time it'll be 1/4. The next time it'll be 1/8. I turn around, I get my slope given my initial x value and the x value plus that delta. And as you can see, as we progress, that delta is going to get smaller and smaller and smaller, just like what we do with limits in calculus. And as we process this, we're going to print out the delta and the slope, basically the size of the difference here, and what the slope is based on that difference. So let's do this. Let me go over here, grab another line of code, and paste it in over here. So I'm going to print a beginning here, and because this is going to generate a lot of information, let's just do the limit for that function at the value of 3. So we're going to do the limit of the function at the value. Come on, my keyboard's just not working. At the value of 3. And for right now, I'm going to take this code and I'm going to come up here and I'm going to comment it out so that it's not going to run. So all that we're going to do here is we're going to do a limits test for x having a value of 3. We're going to see how that slope changes as the delta gets smaller and smaller and smaller. Alright, so let's give this a run. Press F5. Okay, so let's drag that window, make it a little bit bigger so we can see all the values. As you can see, we start with the value of half, a quarter, an eighth, and as this gets smaller and smaller and smaller, we start off with a slope of 6.5. When our difference between x1 and x2 is half, we have a slope of 6.5. As that delta gets smaller and smaller and smaller, it approaches the value of 6. And it stays there. Okay, so as notice that the difference, this keeps getting, anything after 6 keeps getting smaller and smaller and smaller, so that by the time we've done 32 iterations, the slope has settled down to 6. Okay, so we've got these very tiny deltas and a final slope of 6. So now we have generated a program that will actually find the differential or the slope of the curve at a particular point. And that's going to be the end of our third Python program.